The next section discusses IVI repeated capabilities. We'll talk about what they are, the fact that they're implemented 3 different ways, and their use with IVI Configuration Store, and look at both some examples and pitfalls in using them. First, what repeated capabilities are. Turns out a lot of instruments have multiple instances of some sort of same type of functionality. If you think about channels in an oscilloscope, typically there are 4 channels or 2 channels. You think about a spectrum analyzer, it's more of a software concept, but a spectrum analyzer could have a dozen traces, and each trace could have markers on it. So you've got to have, in a general instrument interface, some way to access those things that are repeated, some way to apply an index to those to get to them. And in the case of the traces and the markers in the spectrum analyzer, you've got multiple traces and you've got a marker on each trace. So it kind of looks a little bit like a multidimensional array. So IVI really refers or defines 3 different ways for accessing these repeated capabilities. And turns out Skippy has exactly the same sort of a representation. So if you're familiar with Skippy and you see these cases where there's a number in the header where you're talking about output 1, 2, or 3, it's exactly the same concept. So in Skippy, everything kind of gets grouped into a hierarchy, so that the hierarchy is repeated and you can just apply an index. The very, very similar concept in IVI, but needs to be addressed in a way that works well for multiple instruments across multiple classes. So just to think a little bit about the concept, if you consider something like, looks like I've got a 3 output power supply in my picture. The repeated capability name is channels, right? That's the thing that's being repeated. And then there's something defined by the instrument driver that calls those channels, maybe Chan 1, Chan 2, and Chan 3. There is the notion in IVI that a application can come in and provide a name for those things that's specified by the application. The concern being, if you want to have instrument interchangeability or you want to simplify that, and you have 2 different, in this example, power supplies, and one of them has output 1, output 2, and output 3, and the other has channel 1, channel 2, channel 3, that could end up being another source of variation for your program. So the notion is you got a repeated capability name that really identifies, hey, what we're talking about is channels, a physical identifier specified by the driver, and a virtual identifier specified by the application. So generally the IVI APIs will take either a physical identifier or a virtual identifier for a given API. I won't dwell on this slide. It really just reiterates in detail what I described through the example, that there's a repeated capability name, identifiers that are physical and virtual to refer to the individual repeated capabilities. So within IVI, those repeated capabilities can get exposed in one of 3 different ways. One is every time you make the call to the instrument, you can specify, oh, this call is about channel 1, this call is about channel 2. Sounds like a logical and straightforward thing to do. The problem is that if you really want to be able to write a portion of your application that's focused on working with some detail of something which is in the channel, maybe it's looking for calculating a rise time or something on a trace out there, you don't want to have to worry about which trace it is downstream. So it can be inappropriate to have to carry along the name of the element in every single API. So there are a couple of alternatives to the parameter style. One is a selector approach, and that is you've basically got this big mode switch that says that you want to, we're now going to, all the subsequent calls are going to be for channel 2. and you call that mode switch a little bit later and say all the subsequent calls are going to be for channel 1. Now, you can't look at those intervening calls and tell whether they were for channel 2 or for channel 1, so you kind of have an interesting history dependency in the driver, but that provides a real simple way to kind of change modes between talking to channel 1 or talking to channel 2. And in IVI, that mode switch is normally called set active. That's one of the conventions that it specifies. The third type is a collection. Again, it's a very common approach in that a lot of programming environments, maybe most programming environments, would normally think of this sort of repeated capability as something that would be addressed with a collection of objects or with an array of traces or whatever that might be. So where the languages support it well, collection tends to be a pretty nice approach to these things, and that's used fairly commonly. So it's worth understanding that there's really 3 different ways of getting those repeated capability. Pass it as a parameter every time, set a mode switch, or you model it as a collection. We'll talk a little bit more about what those will look like in a programming environment. So, there are the 3 examples right there. So in our example here, we've got a tray. This is actually a fan tray speed. So the notion is this particular instrument has multiple trays of fans. This is a very high power instrument, and each tray has multiple fans. So if we want to go to tray number 1 to adjust the speed of what's on tray number 1, you could specify tray number 1 as one of the parameters to the function. So this is basically what the parameter style ends up looking like. The selector style, where you're setting with a mode switch, you're basically going to say something like fan tray speed select tray 1, and then you're going to program the speed. So could have been a set active here, but hopefully the example is clear. You're selecting which one you're going to program, then you set the value, as opposed to passing both parameters as they are here. If you think about a collection style, again, that's potentially different. Matter of fact, it is different between different programming environments. But conceptually, you're saying something like my chassis, and then you have this collection of fan trays, and you want tray 1, and then you need to access the fan tray speed. So the same information is being passed to the driver in all 3 approaches. It's just a little different expression to the client program. So this is a list of the attributes and functions that are normally created for the different styles. And don't need to go through them in great details. We're talking about them a little bit because, amongst other things, it just helps illustrate some of the things that you need to prepare to deal with when you're working with repeated capabilities. So if we think about that parameter case first, so we're always passing a parameter to the function. Well, one of the needs that you have broadly is you want to have a way to find out how many copies of that repeated capability there are, and you want to have a way to find out what any given name is. And there are actually 2 ways to do that. One is more COM focused and one is more C focused. But in either case here, we're looking at a name attribute or a name function, however it's built. But you're going to say, I have 10 different repeated capabilities. In our example, I would say I have 10 fan trays. And if I want to know the name of each fan tray, you just say name fan tray 1, name of fan tray 2, name of fan tray 3, etc., up through 10. Now that you've got the names of the fan trays, you can now use the API to access all the fans individually. So presumably, if you're writing a straightforward program for a well-understood instrument, you would just look in the documentation, say, oh, I want to adjust fan tray 7 because that's where my hot stuff is. But in general, you need a way to discover how many fan trays and how they're done. So this count and name API is a way that's done. Turns out the selector approach is about the same. I mean, you need a count and name API to discover what's there. but now you add the additional call that you need to be able to set active to say, this is the active one. And again, some possible variation between how you query that with C or not. It's not too important. Then finally, for the collection scenario, it's very much the same notion. You've got to get a count, you need a way to get the name, and then a way to reach into the collection and get the right element from the collection. And that's done with a call called item. So this is a common convention for dealing with collections, which you also see in .NET. So the driver calls will generally have, and in almost all development environments, will have this item method show up explicitly in your call. Into the item method, you pass the name. Here, you're doing a set active, and of course, you pass the name there. With a parameter technique, the name is always showing up on the function call. So, key takeaways here is that whatever approach is being used for the repeated capabilities, you can discover what's there by using the reading back the count and getting each of their names. Then you can control each of them by name. So here's just an example of what things look like with a trace repeated capability. So it's trace count and trace name, and sure enough, those show up in all three styles, because for all of them you need to discover how many there are and what their names are. And in the case of the selector, you need to be able to do set active. In the case of the collection, you need to be able to get an element from the collection. So here's an example of the selector style repeated capability, and one of the things that is worth being aware of, and that is you may need to select multiple traces at the same time. So one of the reasons that the repeated capability selector is a string is, in many cases, especially in switch type applications, you need to specify more than one at a time. So in this case, we're setting the active trace in a spectrum analyzer to be traces 1, 2, and 3. So when we change the bandwidth or the frequency of the span, we're really impacting all of the traces, not just a single one. So again, since it's a string, it doesn't matter much whether it's a selector style or a collection style, but it is worth noting the difference. So typically for a collection, you'll see something as in this example, where the trace is accessed with an item. So now I've acquired a trace by saying I want item trace 1. So this accessed it from the collection, and now that we have the trace object from that collection, we can set the trace bandwidth, frequency, and span. So clearly, if I'm acquiring this as an object, I may not really want to have an object that represents trace 1 and 2, but it's within the capability of the API that you could. I wouldn't expect very many instruments to support something like that, but you can see how accessing the collection has made it easier to say, I just want to work conceptually with a specific trace and not with the whole driver or with a collection of them. So repeated capabilities show up in IBC, both functions and attributes, because obviously there are things that get repeated of both styles. So one of the things that's common to all of the IBC APIs, which we haven't looked at in detail yet, is that the first parameter is always the session, the VI. The second parameter is always that repeated capability identifier. So the challenge with C is that in the C programming environment, there's not the notion of being able to have a collection of interfaces or collection of objects. Just doesn't make any sense. So the way the IVI APIs deal with that is they actually cross the board in each API have this repeated capability identifier as a second parameter that allows you to specify the VI being the particular driver or instrument, if you will, this being the repeated capability on that instrument, and finally the parameters that are common to whatever we're doing. So the example here is focusing on the set attributes instead of one of the function calls, but you can see that the set attributes have that same second parameter that allows accessing a specific repeated capability for that attribute. So each attribute can now be implemented independently for all repeated capabilities. So clearly necessary if I'm going to have multiple traces, each with different bandwidths and spans. So here's an example of what things typically would look like in IVCOM, especially as we begin now to nest the repeated capabilities. So the example we were on before of a tray of fans with 3 fans in it, is kind of illustrated here, in that I may have a window with multiple traces in it. So typically a network analyzer might be able to display S11, S21, S22, and so on. Multiple windows, each with 4 traces. If I need to be able to set a value on that trace, I need to be able to specify this window and this trace. And so syntactically, we've gone to this collection, got A1, on this collection, gone to S11. And nothing very surprising, because this is exactly the way any two-dimensional data structure would work in Commer.net. And that's what Ivy is striving for, is not to do creative and interesting things, but to do things just conventionally. In IBC, it's a little more challenging because we've got that one parameter to fill in. So you can see that we've invented a syntax where A1 colon S11 allows you to specify those 2 things. So this is a common Ivy syntax for all repeated capabilities, this use of colon to separate the different repeated capabilities. So a few things to be wary of with repeated capabilities from when calling from C is that the string parameter can't be null. You've really got to specify one of the repeated capabilities. And of course, that string's not really going to be looked at by the API until runtime. So you don't get any degree of checking until this is run. There's not a clear indication of when that repeated capability is used or isn't. So in this example, we're talking about this attribute of a multimeter range. The multimeter's only got one range for the whole instrument. It doesn't have a separate channel 1 range. So you don't know when you specify channel 1 here really what the scope of that is. And then similarly, you may use a valid repeated capability, but pass it to a function that's not checking it. So again, all these things, for one reason or another, will give you a compile time error when you try to access it. So there was an example earlier of selecting multiple repeated capabilities at once. We talked about selecting 3 different traces at the same time. Just going into more detail on how that looks. In general, that can be done by specifying either a comma separated list, which is what we saw initially, or you can specify a range. So for instance, 1 through 3 or 8 through 10. Obviously this only makes sense when the repeated capability is accessed numerically, and that's primarily only going to happen when you're referring to a switch of some sort or a switch matrix. But in terms of referring to a range of switches, that's done this way. And of course you can comma separated multiple ones of those to build more interesting lists. So one last point to make on repeated capabilities is that we talked about the fact that there are also virtual repeated capability names. These are names that can be provided by the customer working with the configuration store to provide in names that are more application dependent and allow you to specify names independent of what instrument is running with it, instead of using the names that are specified with the instrument. So there'll be more detail on exactly how to do that in sections that talk more detail about the configuration store. Thank you for your interest in this Ivy training video. There are several other videos available on the Ivy Foundation website, along with Getting Started guides and Getting Started videos. All are available at the URL here, http://www.ivyfoundation.org/resources. Thank you.